This video is going to look at carbohydrates. Before we go into the chemistry, let's talk a little bit about structure. So carbohydrates are polyhydroxy groups, meaning a lot of OH groups, and they have an aldehyde or a ketone functional group. So here we have a aldehyde at the end, which would be a glucose. Here we have fructose, which would have a ketone. So we're saying polyhydroxyaldehydes will be aldoses. Alpha D glucose can be written as a chair, and if you look at our alpha position, notice how these are being drawn. It's essentially directions, right? So in position 1, we're going down, so our OH group is going to be going down. Same thing with position 2. At 3, we're going up. 4, we're going down. So if you have to convert from a Fisher projection to a chair, you can do that. Here you can see why alpha sugars are going to be less favored, because at position 1, we're having that OH group being in the axial position, where on a beta sugar, our OH group would be in the equatorial, the more favored position. Glycosides are formed, and again, similar to what we saw in the aldehyde and ketone chapter where we saw hemiacetals being made. Here we're not going to stop at the hemiacetal phase. We can continue to the acetal phase where our OH group is replaced with a new oxygen and carbon chain. This is the formation of a glycoside, and again, just because we have the equatorial group doesn't mean we also couldn't have the axial group, right? So the alpha and beta group. Let's talk a little bit about this, how this happens. So the first step, just like with acetal formation, remember that position 1 really was originally a carbonyl. So that OH can also be protonated. At this point, you can have a great leaving group with your water. In order for it to leave, it's not going to create a carbocation. The electrons from the oxygen position are going to push down. This should remind you of the acetal mechanism, right? Where we had our double bond oxygen that was positively charged. The difference in sugars is we can have a nucleophile come from the above or below, giving us our beta or alpha sugars. And here, these arrows are the exact same type of arrows we saw in the aldehyde and ketone chapter. You can also have the same mechanism with what's known as an N-glycoside, the N standing for nitrogen, where our nucleophile would be our nitrogen group, and having that become either alpha or beta as well.